Hey guys, so this is 5.1 worksheet. I'm going to be gone for some of you, and so I want to make sure you have a basic idea of the outline and the rules and the things that we're trying to deal with. There are a few properties that we need to talk about, and I'm just going to kind of do them off on the side here, and then we'll pick some problems to talk about. The first property is that if we take something like x squared and we times it by x to the fourth power, x squared is literally x times x, and x to the fourth is obviously x multiplied 4 times. So when I'm looking at this multiplication, I'm actually looking at x being multiplied 6 times. So when we multiply an x by an x or a y by a y, we can add the exponents to produce a new simplified problem, where we don't have to write x multiple times. On the same note, if I take x squared and I try to raise it to, say, the fourth power, this means I have x squared multiplied by itself 4 times. Well, that means I would add up all those 2's. Turns out that this is an example of x to the 8th. Well, isn't there a shortcut? The answer is yes. This 4 can distribute into the exponent. Now this only works if there's no adding or subtracting inside the parentheses. If you had something like x minus 3 and you tried to distribute the square, that's a no-no, because this, exponents are like a rapid multiplication. We can mix rapid multiplication with more multiplication, but we can't mix it with addition or subtraction. The fact that that problem started with a minus in the middle of the math meant that we couldn't mix those styles of math together. A couple of other rules that we need to know. If we have something that is x to the negative third, that is the same as 1 over x to the positive third. And so when we see these negative exponents, remember that a positive exponent means we're going to multiply by x repetitively. A negative exponent means we're going to divide by that x repetitively. And so when we see a negative exponent, that tells us to jump down into the denominator of the fraction and use a positive exponent instead. Along that line, x to the 0 is by definition 1. And truly any number raised to the 0, except for 0, does equal 1. And part of the reason why is that x squared times x to the negative 2 is x to the 0, because we can add those together. But if we think about the property x squared times, instead of writing x to the negative 2 as x to the negative 2, I can write it as 1 over x squared. I would then have x squared over x squared, which we know is equal to 1. Therefore, x to the 0 must equal 1. So again, if you have anything raised to the 0 power, we're going to replace that with 1. And there's really only one other property that we need to deal with. And that property is that if you have something like x to the 5th over x to the 9th, up here earlier when we multiplied x by x, we could add the exponents. Well, when we're dividing x by x, we can subtract the exponents. So we'd minus 5, minus 5. You might say, why do we minus 5, not minus 9? Well, I want my exponent to come out positive. X to the 5 minus 5 is 0, and anything to the 0 is 1 over 9 minus 5 is 4, so x to the 4th. We're going to look at a few problems together now and try to apply these rules. If we had gone minus 9 on both, we would have ended up with x to the negative 4 over 1, but x to the negative 4 belongs down in the bottom as x to the positive 4. And so we still would have had to move it anyway. We're better off just moving the smaller of the two. Okay, let's see if we can clean that up a little bit. That's going to be... that's not going to work. Okay, that's fine. We'll just come over and do the left side. Let's see. We want to come back to... not that. It's got to be in, I just lost myself, didn't I? Okay, so in this set of examples, let's just walk through a handful of problems. Let's start with question number 5. We have a bunch of things to multiply. When we're doing this multiplication, we want to multiply numbers by numbers. So 2 times 3, technically there's a 1 right here. So 2 times 3 times 1 should be 6. X squared times x squared. We get to add those exponents. 2 plus 2 is 4. And over here, this x is an x to the first. So if we go 2 plus 2 plus 1, we should get x to the 5th. So 6x to the 5th. Now that exponent 5 really only belongs to the x. It does not belong to the 6. If we come down to question number 13, I went too far. If we look at question number 13, we have a to the third times negative a to the third b to the 0 all raised to the negative 2. One of the simplest ways we can fix problems like this, see how we have all that stuff raised to the negative 2? We can fix our lives real easily by taking that negative 2 exponent and distributing it. Now here's where we get into a little bit of trouble. This a has a negative in front of it, which means there is technically a 1 in front of it. So now that negative 2 needs to multiply by all 3 of these pieces. But this is important we understand. We're not multiplying by the negative sign. We're multiplying by the 1 in front of, or multiplying the exponent rather. Okay, so this is negative 1 to the first. So my problem would rewrite as a to the third times negative 1 to the negative 2, a to the negative 6, and b still to the 0. That negative 2 doesn't multiply by the bases, it multiplies by the exponents. Okay? Anything with an exponent of 0 goes away. Anything that can be combined, so a to the third and a to the negative 6th, this becomes negative 1 to the negative 2 times a to the negative 3. When we multiply a by a, we get to add the exponents. 3 plus negative 6 is negative 3. Now everybody who has a negative exponent needs to go to the denominator. So I now have negative 1 squared times a to the positive 3. Now we moved everybody down. So as a placeholder, we're going to have to put a 1 on top. The only thing left for us to figure out is the numeric part. Well, what is negative 1 squared? Well, a negative 1 times itself, got twice, is going to come out positive 1. So this is the equivalent of a plus 1, or of a times 1. That doesn't do anything for me, so 1 over a to the third would be my final answer there. If we keep scrolling down, whoops, maybe went a little fast there, looking at a question like number 18. You might want to distribute this 3 right away, which would be fine, but I also notice I could combine my m's and I could combine my n's right away and then do the distribution. M to the 4th times m to the negative 3 would be m to the positive 1, because we get to add those. And n to the 0 times n to the negative 4 would be n to the negative 4. And all of that still has that cube on it. Now I can distribute my exponent to the exponents in the problem. M to the third, n to the negative 12. Well, the things that have a negative exponent need to go down to the denominator so they can have a positive exponent. Instead of multiplying by n negative 12 times, I want to divide by n 12 times. So this will be m to the third over n to the 12th. And there's my answer for question 18. Okay, just one more that we need to look at, and that's going to be question 24. And then you guys can work at your own pace. We see we've got a lot going on down here. I do think it's worthwhile to distribute this exponent down here, but I'm also going to want to combine my x, y's, and z's. I like to do it alphabetically, so here I have an x2 and an x3. When I multiply those, I should get x to the 5th, right? Then my y's, this is y1, and this is y1, so that would make it y squared. And z negative 1 with z3, when I add -1 to 3, I should get z squared. All of that is over. This is important. This 2 has an exponent of 1. The x has an exponent of 1. So that'd be 2 to the 4th, x to the 4th, and y to the 8th. When I go to simplify this, I want to do numbers and then each letter one at a time. This 2 to the 4th doesn't have any numbers above it or on the bottom with it to cancel or to combine. So 2 to the 4th put into my calculator just needs to be evaluated, and that should come out 16. Then I need to look at my x's. See, I've got x to the 5th on top, x to the 4th on bottom. If I subtract the smaller or try to make the smaller one go away, I would minus 4, and I would end up with x to the 1st. Now you don't need to write an exponent 1. You could just leave it as x, but I'm going to do it just for safekeeping. And then I do the same thing with my y's. Well, I have a y2 on top and a y8 on bottom. If I subtract 2 and 2, the 1 on top, well, that goes away because it's y to the 0, and anything to the 0 power is 1. But on bottom, I'm going to get y to the 6th. And on top, I still have this z squared that didn't have anybody to combine with. So there is my final answer. All right, good luck, guys. I hope you can make your way through the worksheet. Try to follow those rules, and we'll see you in class.